Hello everyone, this is Binsu. Welcome to my YouTube channel. In today's lecture and in today's Ansys lecture series, we are basically going to see how you can also do beam analysis in Ansys Workbench. Okay, so let us start it. First thing is you have to open the static structural analysis system. So double click on static structural. So let us see what is the problem we are having. So if we look at the problem, yes. So this is the beam problem that we have, and it's basically a UDL. If you see, it's a UDL, and towards my one end it's a fixed support, and whereas on the other end it's a pin support, and we have a UDL of 1 kilonewton per meter. So let us solve it. The conditions are given to us: material conditions, the Young's modulus. Now here, what is B1 in this case? This B1 is nothing but that is a cross section. So basically, by keeping the moment of inertia into consideration, the cross section has been calculated. Okay, so now let us start with the solution part. Let us see how we can do it in Ansys Workbench. So geometry, basically it was, we have to create that diagram that is given to us. In materials, we are not going to change anything because it's the same as the default material that is taken by Ansys. So in Ansys, by default it takes structural steel, and if you see here, it basically has a Young's modulus of 200 megapascal. So we don't have to create any new material. We will directly start with geometry. I will right click on the geometry cell, click on new design modular geometry. So when the design modeler opens, the unit system that you are going to keep will be with respect to unit system that is given to us. Okay, so the unit system that is given to us is in meters, so we will be also keeping it in meters as well. So if you look here, if I go back to the problem, I guess it is clear to you. So we are having two elements and its length is given as 5 meter each. So instead of keeping it in millimeters, it's always better to keep it in meters for this case. Okay, so by default the unit of Ansys Workbench is in meters. So let us start creating the geometry. I will first select on XY plane, click on the sketch icon, and then I will click on this look at face. Now I will go to sketching, line, create the two lines. Now we have to give the dimensions. So dimensions to both the line elements. So they are both 5 meters. So I'll just write here 5 meters in the dimensions tab over here. Now we have basically completed with the sketching of the profile. We have to convert this into line bodies. Only then you can apply beam analysis in Ansys Workbench. So how to do that? You have to go to concept, and I will click on line from points. Okay, so I will select this point. What you can do is you can make the isometric mode on by clicking on this blue dot. Select this point, press Ctrl and select this, click on apply. So this is my first line body element. Click on generate. Again I'll go to concept, line from points, select both of these points by pressing the Ctrl key, click on apply. Now make sure you are under operation with changing this to at frozen, because only then Ansys Workbench will consider both these as independent line bodies, and we need that for our analysis. So just make it to add frozen, click on generate. Now what is the next thing we have to do? We have to add the cross section. So go to concept, cross section, rectangular, So cross section basically, if you see the unit system has come to meters, the cross section that is given to us is in mm, which is 124.46 mm. So what I will do here, I will change the units to millimeters, and here I will write 124.46 in mm, and then also 124.46. So basically we have taken it as a square cross section. Okay, again we will create another cross section. Now here the cross section is 104.66, that is for the second element here. So I will write here 104.66, this also 104.66. Okay, so we have created both the cross sections. Now we have to assign these cross sections to the line body that we have created. How to do that? Just expand this, two parts, two bodies, click on line body. So you see cross section not selected, click over here under not selected, select the drop down arrow, this I will change to rectangle 1. Similarly select the second line body, this I will change to rectangle 2. This is our second cross section. Click on generate. Now if you see in the geometry tab, it is considering it as two parts and two bodies. We need it to be considered as a one part with multiple bodies. So how you can do that? Just select both the line bodies by pressing the control key, then right click and click on form new part. Now you see it has converted to one part, two bodies. Now if you see still it looks like a line, and if you need to see the cross section, we can go to view and activate cross section solids. So you see, you can see the cross section over here. Okay, so this completes with the geometry modeling. I will go to file, close this, and now we will assign all the boundary conditions in the model cell. Okay, now basically open the model cell here, double click on it. So what we did earlier, that is in the engineering data and the geometry, is nothing but the pre-processing stage. Okay, and still the pre-processing stage of the FEA part, that is what we are doing in Ansys, it's still not completed. Okay, so we have to yet assign the boundary conditions that is given to us in the problem. So now the model cell is opening. It will take some time to open, depending upon the system configuration. So now what we are going to do here, we are going to assign the boundary conditions. So I'll click on static structural. First thing is we have to apply fixed support towards the left side. So I'll click on fixed support, make the selection mode to vertex, select this vertex, click on apply. Okay, and we need to give a pin support on the other end, right? So how do you give that? So pin support basically means XYZ displacement is 0, only rotation about Z is fixed. Okay, so I'll first give a displacement, select this vertex, click on apply. So here you see XYZ component, so here I will write all these values as 0. Now we also need to give the rotational constraint, that is it should only rotate about Z. How to give that? Again, just click on this support drop down arrow. Here we have something called as fixed rotation. Okay, now select this particular vertex point, click on apply. Now it should be able to rotate only about Z. So I'll make this as free. Rotation about X and Y, I am keeping it as fixed. Okay, now what is the next thing we need to do? We need to apply the load. The UDL is being applied, so that we will get under the loads tab. Click on this. It's a line pressure, so you have an option of line pressure which basically acts as a UDL. Select it. I will click on this line, click on apply. Now what is the value? What is the value of load we have? You check the load value, it's basically 1 kilonewton. Okay, so what I will do here, I will first change this by components. So it's in the negative y direction, and here I will write -1 E3. It's -1 kilonewton because load is acting in a downward direction. Okay, so now in the solution part, what I will need the total deformation, and then now you go to insert. Now you see here the beam results. Now this will only get activated provided you have created the geometry by the line body approach, else you cannot see this beam results. So what I need the shear force. I will right click, and then I need the bending. Okay, I will click on solve. So there are some limitations here, like when you numerically solve the same problem using the FEA methods, so basically you get slope as well as the deformation. So here we won't get the slope part, we only get the deformation. Okay, so now what are the results? If you check the results that we have, so these are the results. So basically we are going to get this, okay, this particular result, that is the displacement at this particular node, and this is what I mean to say as the slope. So we are not going to get the slopes. Okay, so let us see what are the results we are getting in Ansys Workbench. Yes, so now it has solved. So if we go for the deformation, now W3 is nothing but at this node. Okay, so now how to get the value at this node? I will click on probe, bring it here. So you see it is almost same as the answer that we have, 0.0155. Yes. Now we need to, this Q1 is nothing but the shear force, Q1 and Q5. Let us see that. Look the shear force. Now if you look here, if those who have made the shear force diagram, now things should be more clear here. Over this side the force is constant. You see here it's constant force. So we had this as one force, and at the other end we are having this as the load. So how much we have? 1.9 kilonewton and 2.8 kilonewton, which is approximately matching with our theoretical answer. And then we have one more thing, that is the bending moment. Okay, so bending moment, you will click over here, bending moment. If you see, we have the maximum bending moment that is at this location, okay, which is 6.9. I will again use the probe, 6.9 kilonewton. Okay, so this is how you can do a beam analysis with a UDL load using Ansys Workbench. So I have done it in Ansys Workbench 2020, that is the latest version. It's a student version, you can also download it free in the Ansys website. So thank you for watching my video. If you like the contents, please do subscribe and like the video. I would be happy to address out your queries in the comment section. Thank you.